Yeah, hello everyone. I'm back, and I hope everybody who is listening to me right now is safe and sound and investing a lot of time in coding. And in today's video, we would be solving one problem from the August LeetCoding challenge. Let's move straight away to that problem. The title is Numbers with Same Consecutive Differences. What we need to do is we need to make as many numbers whose length is n and the absolute difference between any two consecutive digits is k. Okay, and we cannot have leading zeros if n is greater than 1. Let's see this example. For n equal to 3 and k equal to 7, so the difference between any two consecutive digits should be 7, and the total length of all the numbers like individually should be 3. So these are those possible cases, and we need to return a vector or array of those all such possible numbers. So yeah, let's open this problem in a separate tab. As you can see here, the constraints are very small, so we can do it just with easy recursive function. We do not even need the dynamic programming. I've already solved it. Let me just explain you what I did. First of all, I initialized a global variable. Here I would be solving I would be storing all such possible numbers. Okay, and let's come to the main problem, main function. Here I'm handling the case where n equal to 1 separately. Like, yeah, I do not want to handle this in my main solve function. It would kind of make it a bit messy, and I do not want it. Okay, so for n equal to 1, there can be only n possible cases. Whatever the difference be, the numbers would be 0, 1, 2, 3 to 9. Okay, let's take an example. Let's say n equal to 1, and let's run the code for that. Yeah, so as you can see, the output is 0, 1 to 0 to 9 irrespective of the value of k, because we only care about one digit. And let's try to handle the other cases. For all the other cases where n is not equal to 1, the first digit cannot be 0, as we are not allowed to have leading zeros. Okay, so I'm passing the first digit from as I, and I starts from 1 and ends at 9. Okay, and here the second argument to my solve function is the count, which tells me how many digits have been already included, the number of digits which have been included till that point in my number. Okay, and I pass the value of k, and then here, yeah, and if count is equal to n, that means we have already found that possible number, that we have included n number of digits, and during the process we were also following the condition, that is the absolute difference between any two digits should be equal to k. Okay, and if count is equal to n, we'll just push the temp value. Temp is the current running number we are having. So what we are doing, we are adding one digit one by one during a recursive call, and at the end, if count is equal to n, that we have at this point we are having n number of digits in a number, we push that to our global vector, that is nums, and return from there. Okay, now let's see if we haven't reached the point where number of digits in our number is equal to n. What we do, we first find out the previous digit. Suppose I found my current number is 12, and now I want to find out the third digit. Okay, then in this case the previous digit will come out to be 2. Okay, and new num, I would be calculating new num according to the value of k. Let's take this example, the 3 and 7 one. Yeah, 181. Suppose I've passed 1 to it, and here the previous digit is 1. Now for calculating the new num, what I would be doing, I will subtract k from 1, and in the second case I will add k to previous digit, and I'll see that after subtracting it should be greater than or equal to 0, because the range of digits can only be from 0 to 9, and after adding k to the previous digit it should be less than or equal to 9. Okay, and if it is so, I will find out the new number. What I will do, I will do 1 into 10 plus the new digit will come out to be 8 if k equal to 7. Okay, and in this case for 1 we no, in this case we cannot find the new num, because here we are subtracting k, and by subtracting if I do 1 minus 7, it would be less than 0. So here we will not go inside this if loop, if not loop, if condition. And if I add here 1 plus 7 comes out to be 8, which is less than 9, so we'll just add 8 to our previous number into 10, that is 1 into 10 plus 8, and it comes out to be 8. Then we'll pass 8 into the new recursive call. Okay, and we will increment count as we have added one new digit to our number. Keep on doing it, and for 18, let's say I'm in the second recursive call, for 18 I'll find out the new digit I can add. For 18 I can add 1 to it, because from 8 I can subtract 7 and still the number is greater than or equal to 0. So then 18 into 10 plus 1, that will result in 818, and when I pass this to the new recursive call, I will be seeing that count is equal to n. I will simply push 181 here to the global array, and here we are sure that we will only be pushing the valid numbers in our global array, because we are only pushing the digits if it is a valid digit. By valid I mean it is following the condition that the difference between adjacent digits should be k. Okay, yep, and I've placed this extra condition in the second if loop, because if k equal to 0, then prev digit minus k and prev digit plus k is same, there's no difference. So I only need to check that if condition only once, if k is equal to 0. So yeah, I hope you got the point. Let's try submitting it. I've already submitted it, but I am just doing it for the sake of video. Yep. So yeah, I hope you like this video, and we will try to solve this monthly challenge problems on daily basis. So okay, so if you have watched this video till this point, thank you so much, and if you like our videos, please like and subscribe. I'm done. Take care, sayonara.